All right, welcome to Geometry. This is section 10.5 again. This is day 2. So yesterday we discussed information that will help you get this worm up here. So if you have not already done so, please try to fill out all the measures you can. If you see a segment go through the center all the way across, so the center here is at C, that is a diameter. It does split the circle into 2 equal parts. So 180 degrees for the arcs on top and 180 on the bottom. So keeping that in mind, I'm going to fill in missing arcs of the circle. So that's an 88 and this is a 95 degree arc. And then just see what I'm looking for. M-O-N, M-O-N. So since it's on the edge of the circle, you find the arc. It's in between its two sides, so that's 85. And divide by 2, so that's 42.5. MCN is directly at the center, so you just take that 85 in. A and I, so even though it's on a tangent here with a chord, it's on the edge of the circle, so you treat it just the same as the other one was. So you take the 92 this time and divide by 2, so that's 46. And then OIN. Now OIN is a special one because anytime it touches the ends of a diameter here, you will get 180 degrees between those two. So anytime you're touching the two ends of the diameter, you automatically get a right angle in there. Alright, so that ends some of the review from yesterday. Now going on, we talked about yesterday the location of the angles. So when it's at the center of the circle, the arc the angle faces just comes right in. So it's that measure here goes to the center. If it's on the edge of the circle, then we take the arc it's facing and divide by 2. Now we're going to talk about 2 other situations today, and no matter how they are made, we're looking at locations being inside the circle, and we're looking at locations being outside the circle. So angles are going to be made inside the circle, like on this one, or they're going to be made outside the circle on these, and there will be one other example there. Alright, so next one is a chord. So an angle whose vertex is inside the circle but not at the center. Now, typically, you can have one that's at the center, but then we start automatically going back to the one up above where it's like at point C where you just take it in. So this is particularly helpful when you have it going inside the circle, but not at the center. So maybe I should put, but usually not at the center, even though it can be. Alright, so when you do this, we're going to take, I'm going to draw a little picture here for you, so I'm not going to mess with the numbers on that one. So when you do this, you're going to have it, so if I'm referring to that angle, you're going to use its vertical angle here, because those two should be equal. And now when you do this, the arcs, both of those face, are going to be important. So I'm going to take so inside angle is going to be the arc it faces plus the arc the vertical angle faces, and we're going to add those up and we're going to average them because I can't have an angle and a vertical angle having different values. So for example, on this one, I can't take the 50 in here, and I can't take the 65 in here, and I can't take the 95 in here. It'd be great if you could, but we still have to follow the properties that vertical angles are congruent, so these are not. And we also have to follow that supplements or straight angles are something like 180. So we have 145 here, we have 160 here. So that doesn't work when it's not at the center. So what we do then to face it, so AYT, so I'm really looking for this angle. What I do is I take the angle it faces plus the angle the vertical, the arc the vertical angle faces, and I just average them, and that way both of them will be using the same numbers. So I take the one it faces, so the arc it faces plus the arc for the vertical angle. It's really a hard description. So 65 divided by 2. So average them and they're both to be the same thing. So 115 over 2, which is 57.5. So it means this angle would be 57.5. And also we would use the same number. So vertical angles still apply to that one. All right, so inside we take the two arcs, we add them up and divide by 2. Now you're going to see a couple situations where they're not inside anymore. They're going to be, the angle is actually going to be outside the circle. So the first one is a secant secant. So it kind of looks like that. Almost looks like a nose on a bird or something, or a bill on a bird, where it goes all the way through. So an angle whose vertex is outside a circle, and sides are 2 secant 6. Okay, and really when they give you the secant secant and then the next one they give you tangent tangent, it's really, they tell you what it's being made from. So an angle whose vertex, so an angle whose vertex is outside, so again the consistency is outside the circle, and sides are 2 tangents. This one I refer to as the ice cream cone. Okay, you have this, you have a tangent and a tangent. Reminds me of an ice cream cone. You got something else? Go ahead and tell me. Secant tangent or tangent secant, doesn't matter really the order, so it's an angle whose vertex is outside and is made, or sides are made by, a secant and tangent segment. Segs, I guess. Alright, so you'd have your circle. On one side you'd have a tangent, and the other one you'd have a secant. Maybe that's better. Okay, so irregardless, all three of those, the angle is outside the circle. It's outside the circle. It's outside the circle. Anytime we are outside, so an outside angle, you take the far arc at the two sides intercept minus the near arc and divide by 2. So every single one of these we're averaging or dividing by 2 except for the one at the center. So when I'm talking about something outside, when you see it outside, you trace the two sides. Oops, sorry. I'm trying to figure out that one. So I want the far arc, so this is my far one between my two sides, and this is my near arc. So in relationship to the angle, the far one outside it, and it should be bigger than the near one. So is equal to 150 minus 50 over 2. So that comes out to 50 degrees. On the secant secant, we do the far, and we have the near. So BEY, we do 90 minus 40 and divide by 2, so that makes 25. All right, that's where we're going to stop for tonight. See you tomorrow.